every user is supplied with a key pair pk comma sk. So this is pk is set to be the public key, sk is the secret key. The public key may be announced out. That means one can announce the public key to the members in the communication. Whenever anyone wants to send you a message, they will encrypt the message using the public key and will send you. You are supposed to use the secret key of yours and you are supposed to decrypt the encrypted one. And this secret key must be kept secret. That means it should not be disclosed out. Only you are supposed to keep this particular secret key. And everyone will be getting a unique public key and secret key pairs. Okay. And this one, this particular public key and secret key pairs are both the keys can be used for both encryption and decryption. That means you may do encryption with the public key and decryption with the secret key. And also you may use secret key for the encryption, you may use public key for the decryption. So both keys are used for encryption and decryption. In case of the achieving confidentiality, the confidentiality can be achieved with the help of encryption. In case of encryption, anyone can encrypt a message using the public key. Only intended receiver decrypt using the secret key. This is a general way that we are aware of. But in case of signatures, or we can say digital signature means you are going in general. Normal signature means you will put your signature on the document. So whenever you put the signature on your document, the one who knows about your signature may check that whether it is your signature or not. That is in general procedure. While coming to in a digital world, any document will be signed, that means will be encrypted using the secret key of the person. Anyhow, the public key is known to anyone. The public key will be used for decryption and for verification. So that in future, that sender cannot deny that I have not sent the message or I have not signed the document, because signing will be done using the secret key. We just now discussed that the secret key must be kept with that user only. It should not be disclosed out. So when it is not disclosed out, obviously who knows this secret key? Obviously the person who signed that or who sent the message. So he cannot deny in future that I have not sent, because secret key is known only to the person. No one knows this secret key. So that is a possibility that only with this secret key, only that person can do this particular operation. So this is the way signature property can be achieved. So encryption means anyone can encrypt the message using public key and only intended receiver decrypt using secret key. While coming to signature, encryption will be done using secret key, verification will be done by anyone using the public key. In this public key algorithms, public key distribution schemes will be there, public key encryption schemes are there, signature schemes are there. And there is a popular public key encryption and encryption algorithm or public key cryptography algorithm called RSA, which is a very popular in the public key algorithms, especially in the wired networks. But this RSA is not suitable in implementing in the blockchain. The reason is, what is the wrong with RSA? RSA is based upon the belief that the factoring is difficult. Basically, this RSA algorithm will work on the prime factoring. So prime factor, they will take the large prime numbers or biggest prime numbers, and they will do the factoring of the prime numbers. And based upon the factoring of the prime numbers, the rest of the operations will go on. Actually, the belief in RSA algorithm is factoring of the prime numbers is difficult, but it was never proven. If you have sufficiently large processing capability, factoring can be done easily. And one more thing is, prime numbers are getting too large. It is very difficult to remember what the prime number they have used, or when the prime numbers are very large, too large, then the related data type is also required to hold it. For example, if I have given integer value, integer range will vary from minus 32,676 to plus 32,675. Because integer occupies 16 bit, so 2 power 16 is the range that you will get. But if you take a large prime number, what is the suitable data type for that to hold? So data type data type to hold that is also very difficult. If you look at popular languages, any popular language, their data type will be holding certain digits only, not more than that. If you look at MATLAB also, you can get a value which is maximum of 60 factorial. But in Python, you will get up to 100 factorial also. It depends upon the programming language that you use. So prime numbers are getting too large. Amount of research currently devoted to factoring the algorithms. Actually, that means the prime factoring. Many of the people are working only on the prime factoring. Total time was devoted only on the prime factoring, in how efficiently you do the prime factoring. And also the recent invention, that is quantum computing, will make the RSA obsolete in overnight. Because the quantum computing nowadays, theoretically, they are proving that prime factoring is very easy using quantum computing. RSA can be broken within a night. So that is the reason. These are the things. Actually, the blockchain has been developed by keeping in mind that for next 100 years, something should be done like that. So hence, if these kind of things are there, it is not better to use RSA. So we require some new algorithm. Conventional RSA algorithm is a famous public key algorithm. However, elliptic curve cryptography. I hope many of you might have listening this particular algorithm for the first time. Elliptic curve. It is not ellipse. Please make note of this. This is not ellipse. Ellipse is different. Elliptic curve is different. Elliptic curve cryptography is widely used today as the security strength of 307-bit private key RSA can be achieved using 256-bit private key of ECC. That means in the last lecture, when I am discussing the strength of the security algorithm, the strength of the security algorithm totally depends on the key length that you use. For example, if you look at the UPI payments app called Beam, whenever you perform a transaction, the Beam application will make use of RSA 2048-bit encryption for the transaction. So breaking 2048 within seconds is very difficult nowadays. So the reason it is too much successful. But if it is a wired network where many users are involved and sometimes mining process is also involved, so obviously we require some sufficient time for doing the activities. So in such cases, there is a possibility of breakage. So as the length of the key increases, the security strength also increases. The 3072-bit private key RSA strength is considered as the one of the top security strength for the public key algorithm. But the same strength that you achieve with the 3072-bit key, that you can simply achieve using 256-bit key of elliptic curve cryptography. That means with small key length, you are achieving higher security than RSA. That means ECC offers greater security using small key length. That is the reason nowadays no one other than RSA, many of the people are working on the elliptic curve cryptography and improving the algorithms using ECC. That is the reason we are going to see the elliptic curve cryptography in this lecture. So what is exactly an elliptic curve? Elliptic curve is not ellipse. please note that ellipse equation is different from the elliptic curve. Okay, what is elliptic curve actually? Elliptic curve is an algebraic equation with some conditions to be satisfied. The algebraic equation is like this: y square is equal to x cube plus ax plus b. This is the algebraic equation, represents the elliptic curve. What type of elliptic curve it is? It's a non-singular elliptic curve. Here you can take any values of a and b, but you are supposed to check for 4a cube plus 27b square not equal to 0. That means you can take this particular equation, you can substitute any values of a and b. But using this a and b, if you put this a and b values in a 4a cube plus 27b square, it should not be equal to 0. Okay, such curves are said to be non-singular elliptic curves. We will say a elliptic curve is a singular elliptic curve if 4a cube plus 27b square is equal to 0. So we should choose the a and b values in such a way that to have a non-singular elliptic curve, we should choose the values of a and b in such a way that 4a cube plus 27b square not equal to 0. Along with this condition, there is another condition that together with a special point at O, which is called point at infinity. So we are going to consider an elliptic curve equation, which is an algebraic equation. This is a curve equation, and this curve equation will be, along with this curve equation, we'll also considering a point which is called O, which represents the point at infinity. That means this particular point will never touch anywhere, will directly touch the infinity. So these three should be there to represent a non-singular elliptic curve. Always we are supposed to consider a non-singular elliptic curve. The reason is, if you consider a singular elliptic curve, you cannot generate unique solution, you cannot generate unique points on the singular elliptic curve. You will get the generated points again and again on the singular elliptic curve. If it is non-singular elliptic curve, then you will not get this particular problem. So that is the reason it is always recommended to use a non-singular elliptic curve for implementing the elliptic curve cryptography based algorithms. Here are some references that I have provided. Let we'll go through these references for understanding of how the elliptic curve looks. So here, first one represents the standards for elliptic curve cryptography group. So this is a group, it's a group which will decide the standards for elliptic curve cryptography, in which you have several documents placed in this. What are the standard elliptic curves that to be considered for generating the public key algorithms, or for designing the public key algorithms using elliptic curves. So here some elliptic curve specification documents are there. SEC1 elliptic curve cryptography version 2.0, recommended elliptic curve domain parameters. Okay, so it is a very detailed document. It's a detailed document consisting of recommended elliptic curve domain parameters. So what are the recommended parameters over the domain? So what are the equations? What is the equation and what are the values of A and B to be considered? So these are the standard equations that to be considered for implementing strong security algorithms. So this link was provided in the slide. You can go through this. Next one is elliptic curve certificates, and other documents were also placed here. So if any updations are there in the standards deciding about the elliptic curve, they will update in this particular website. Now if you look at the elliptic curve will look like this. This elliptic curve equation is like this: y square is equal to x cube plus ax plus b. Now b is equal to 2.6 here. I am changing to 1, and a is equal to -1, I am changing to 1. Now you look at the curve equation change, curve design also change. Okay, so whenever I substitute 1 and 1 in the 27 a square plus that equation, that is 4a cube plus 27b square. So obviously 4a means 4a cube means 4 into 1 cube plus 27b square, 27 into 1 square, which will not be equal to 0. So that is the reason what are the parameters that I have considered a and b as 1, 1 are the acceptable parameters, and the curve equation that I have considered is y square is equal to x cube plus 1x, which is x, plus b is equal to 1, so 1. So the curve equation that I have considered is y square is equal to x cube plus 1 x plus 1. And now I need to produce the x and y points from this elliptic curve equation, so that points will become the public key. That points will become the public keys of for your elliptic curve algorithms. So if we solve for x and y, obviously you will get some points for the x and y, and this particular y square and this particular y square and this particular y square value, how you can solve this? So in always whatever the keys you generate, that should have some domain range. Okay, all the values should be produced in the range itself. So when can you produce any values in the range? You can produce the values in the range when you go for the modulo operation around the particular function. So that reason we'll take a prime value or prime number with which we perform the modulo operation by varying the values of x and y's, so that we will get the points over this particular elliptic curve. That means the ultimate aim is we need to get the points over the elliptic curve. So whenever the equation was defined, now on a line, we all know that there exists multiple points on the elliptic curve. Okay, we find see, if you draw a line, how many points are there on the line? So obviously there will be infinite number of points on the line. So we need to generate some points over the elliptic curve. And if you look at this curve, where it is ending, this red line is keep on going. You don't know where it is ending. It is very difficult to identify where it is ending. Not in the upper dimension, but also in the lower dimension, also in the lower axis also, where it is going. It's keep on going. So that is the reason in the definition of the elliptic curve function equation, we have decided that we need to consider an equation, algebraic equation called y square is equal to x cube plus ax plus b, along with a point at infinity, which is called O, because we don't know where this curve ends. That is the reason we are also considering a point O, which is going to be ended at infinity. That is the curve that you can look at for the understanding of the how the elliptic curve looks like. So this is the diagram this is a representation of the elliptic curve, how the elliptic curve looks like with respect to the algebraic equation y square is equal to x cube plus ax plus b. So you can take whatever the values of a and b you want, but if you substitute this a and b values in this equation, it should not be equal to 0. Then it is a valid elliptic curve equation with a special point O at the infinity, because we have seen that curve will not touch any point. In the first coordinate of the first coordinate of the coordinate axis, and in the fourth coordinate also, you know where the particular point, that particular curve is ending. So it's keep on going. So the reason we always consider a special point, which is called point at infinity. So with this, you come to know how the elliptic curve equation was defined, and we always consider non-singular elliptic curve because this particular equation is not equal to 0. If it is equal to 0, then it will become the singular elliptic curve. We should not consider single elliptic curves for the cryptography algorithms implementation. And we need to produce the points over the curve. So in order to do that, we require to consider a prime number, and we need to modulo with this particular, we need to perform the modulo operation with this algebraic equation. And the p value must be greater than 3. Whatever the prime number you take, the prime number value must be greater than 3. So if you consider p is equal to 1, it is not, you cannot get any point over the curve. So obviously the point you will get based upon the number of points that you want, and that means this p value to be chosen based upon the number of points you want. For example, in our lab we have around 40 computers or maybe 50 computers. Let's say assume that 50 computers are there. Now I want 50 keys, because the public keys are unique to each user. So if there are 50 computers, I require 50 keys. 50 keys means 50 points I need to generate. So if I want to generate 50 points, p must be greater than 50. So that is the reason you take a prime number which is greater than 50, you may consider 53. When you consider 53, obviously you can generate maximum of 52 points. So 2 points may be in spare. If anyone wants, they can use it. So like that, depending upon the number of users, you are supposed to select the prime number. Now assume that you have 200 members or 200 users. Then how much value of p that you are supposed to consider for producing the public keys? So obviously a prime number which is greater than 200 to be considered. Okay. So let p is greater than 3 be prime. The elliptic curve equation y square is equal to xu plus ax plus b over zp is a set of solutions x comma y which are belong to zp cross zp to congruence. Congruence means modulo operation, where a belong to zp and b also belong to zp. Whatever the a value and b value you consider, that will be fall under the same domain again. Are constant such that 4aq plus 27b square not equal to 0 together with the special point infinity. This already we have seen. That means to produce the values of x and y, we need to modulo with p, and p value to be considered based upon the number of users we have. Okay. So and we should also consider this, whatever the points that will be generated will form an abelian group. Abelian group means if you sum up 2 points, again the resultant point will fall under the same group. Such kind of groups are said to be the abelian groups. So this particular operation should lead again to the abelian group. So such points to be considered as the public keys in the elliptic curve. If you look at an example from the NSA security agency, where curve P192, a curve P192 will be considered. So P192 is a standard curve decided by this elliptic curve standards organization, as I have shown just now. There they have considered the prime number like this. This is a very huge, very long prime number they have considered, which is of 192 bit. This prime number is of 192 bit prime number that they have considered. And they have considered a value as this much and a b value as this much. Okay. And they have used some r value like this and gx and gy values. So x square, the equation. So y square is equal to x cube plus this is a value, ax plus b, this is the b value, modulo p, this is the p value they have considered. Okay. So from where they are going to get it? They are going to get this particular curve, they are going to use these curves with the help of the standards fixed by the elliptic curve standards organization. These curves are available online. You can consider those values and you can use for your programming also. So this is an example, real example of the from the NSA, what the curve they have used and what are the corresponding values. So here is a singular elliptic curve. Singular elliptic curve means whenever it is equal to 0, then it should be singular elliptic curve. We should always consider the non-singular elliptic curves. And we have seen the abelian group, that whatever the curve you consider and what are the values you consider, that should follow the abelian group. Abelian group means in which the group means in which G is closed under the addition. That means whatever the values you take for the A and B or X and Y, that X plus Y should fall again under the same group. Plus is associative, that is X plus Y plus Z is equal to X plus Y plus Z within the brackets. G has an identity element E, so X plus E is equal to E plus X. So you should get the same result back. G contains inverse Y is equal to Y plus X is equal to E, that is X plus Y is equal to Y plus X is equal to E. So inverse should also be satisfied. And an abelian group contains the rule of a group, but the following must be meet the following criteria. Plus is commutative, that is X plus Y is equal to Y plus X, because you will encrypt from one end, and if you send other side with the private key, they should be in a position to decrypt it. Okay, so this is the reason X plus Y is equal to Y plus X. If this is commutative, then it will fall under the abelian group. Abelian group will have the properties that we have discussed 1, 2, 3, 4. Along with this one, commutative law should also hold. In such cases, that particular equation and the values that you consider are said to be will be falling under the abelian group. Abelian group means, for example, if you consider the prime number as 53, whatever the values that you generate will again fall under the 0 to 52 only. So whatever the operations you do on that particular group values, again the resultant value will come under the same 0 to 52 only. In such cases, we'll consider that we'll say it as the abelian group. So anyhow, this particular slide we have discussed it, and here is the very a simple example. We can say a simple example has been given how to produce the public keys with the help of the elliptic curve equation. A simple example has been given here. You are supposed to listen it carefully, because how you are supposed to generate the points on the elliptic curve, and these points are used as the public keys. Now here I'm going to consider a small prime number 11. 11 is a prime number. Now I want to generate at least 10 public keys to be used by 10 members. So I have considered the elliptic curve equation, which is a non-singular elliptic curve equation. Y square is equal to x cube plus ax. A is 1 now. Ax plus b. B is 6. A is equal to 1 and b is equal to 6. If you substitute a and b value in the equation, obviously it is not equal to 0, because both are positive values, so it will not become 0. So that means this equation will become the non-singular elliptic curve over Z11. Z11 means I am going to use the 11 as a prime number. That means modulo prime number 11. Now x is there. That means whenever I am using the prime number as 11, what are the maximum values that I can generate from 0 to 10? Because modulo operation will be up to the modulo number minus 1 only. 0 to the modulo number minus 1. Modulo operation will always give you the remainder, not the dividend. Division is different, modulo operation is different. In division, you will get the dividend value, but in case of modulo, you will consider the remainder value. Okay. x is equal to 0 to 10. For example, if 11 is there, if I want to modulo 11, that means I want 110 modulo 11. So what is the resultant value I will get? Okay, 110 modulo 11 means 11 tens are 111. The remainder is 0. So like that we will get. We will consider 0 as the remainder. So what are the maximum possible values that you will get? 0 to 10. So substitute each value in the right hand side. Now 0 cube plus 0 plus 6. 0 cube plus 0 plus 6. So what is the meaning of that? 0 cube plus 0 plus 6. That means it is 6 only. Now 6 modulo 11, what is the value? Anyone can say? If you substitute 0, 0 cube is 0. 0 plus 6. 6 modulo 11 is 6. Okay. Next 1. You substitute 1 in this. 1 cube plus 1 plus 6. 8. 8 modulo 11. 8. 2. 2 cube 8 plus 2. 10 plus 6. 16. 16 modulo 11. 5. Because 11 ones are 11. 16 minus 11 is 5. The remainder is 5. So we'll consider 5. 3. 3 cube 27 plus 3 30 plus 6 36. 36 modulo 11. 11 3s are 33. 36 minus 33 is 3. So we are going to get the value 3. Like that 4 cube plus 4 plus 6 modulo 11. We will get the remainder as 8. 5 cube plus 5 plus 6 modulo 11. We will get the remainder 4. Next 6 cube plus 6 plus 6 modulo 11. We will get the remainder 8. Next 7 cube plus 7 plus 6 modulo 11. We will get the remainder 4. Like that you do for up to 10. 10 cube plus 10 plus 6 modulo 11. You will get the value 4. Now you keep like these values. Now RHS is over. Now you consider the LHS, left hand side value, y square. Assume that the same operation, y square. If y is equal to 0, if y is equal to 1, if y is equal to 2, like that you substitute the values and perform the modulo operation with 11. The modulo operation should be done for left hand side as well as right hand side also. Now y square, if y value is 0, okay, y value is 0, so y square is 0 square, which is 0 modulo 11, so which is 0 again. Okay. Next is 1. 1 square modulo 11. It is 1. Next 2 square 4. Okay. 2 square is 4. 2 square is 4. 4 modulo 11. Which is 4. 2 square is equal to 4 modulo 11. Okay. Next 5 square. 5 square is equal to 25 mod 11. So what is the resultant? You will get 3. Next is like that you do up to 10. Now for which value of y you got the result of right hand side? For which value of y you got the result of right hand side? For example, you consider 4. Y is equal to 4. You are supposed to listen it very carefully here. When y is equal to 4, y square is 16. 16 modulo 11 is 5. So for the value of 4 to y, you got resultant as 5, which is equal to right hand side. Which is equal to right hand side. Because on right hand side, for 2 you got the result as 5. 2 cube plus 2, that is 8 plus 10, 8 plus 2, 10 plus 16 plus 6, 16. 16 modulo 11, you got 5. Okay, for 2 of x you have 5. At the same time, for y value as 4, you got 5. So that is the reason the pair that you get as x comma y is 2 comma 4. That is the first point you got. Next, for what value of another value of y, you got the same resultant or remainder as 5. 7 is there. 7 square is 49. 49 mod 11. 49 mod 11 means 11 4s are 44. 49 minus 49 minus 44 is 5. So for y value as 7, you got remainder as 5. So 2 comma 7. This is another point you can make. That means if you substitute x as 2, you got the same value. For if you substitute 7 in y, you with modulo 11, you got the same value. LHS is equal to RHS. That is reason you got x value as 2 and y is 7. In the first point, x value as 2 and y as 4. Like that. If you look at 5 square, 25. 25 modulo 11 is 3. And for value of x is equal to 3, you got the remainder as 3. So 3 comma 5 is another point you can make. 6 square, 36 modulo 11. 11 3s are 33. 36 minus 33 is 3. So 3 comma 6 is another point. Like that, if you find the same remainder, for the values of x and y, you make a combination of x comma y of those values, so that you form the value, you form the points like this: 2 comma 4, 2 comma 7, 3 comma 5, 3 comma 6, 5 comma 2, 5 comma 9, 7 comma 2, 7 comma 9, and 8 comma 3, 8 comma 8, 10 comma 2, and 10 comma 9. Along with these points, in the elliptic curve equation, we have also seen there is another point called point at infinity. So this point at infinity is also to be considered. Now the number of the prime number that I have considered is 11. The prime number that I have considered is 11. So how many public keys I generated? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and point at infinity. So we'll keep the point at infinity aside. Totally 12 points I got. That means sometimes I will get one or more than the prime number that I have considered. So these 12 points are sufficient for me to allot to 10 users. These are the public keys that I will assign to the users. This is the way how the public keys in the elliptic curve will be generated. Then you may ask me, what about the private key? You can take whatever the number you want, okay, whatever the favorite number you want as the private key,